This is an interesting problem to 14 from 4.1, and it's not necessarily clear on how to really approach this problem. It is something you may have seen in 181 maybe, but it's okay if you hadn't. This is a little bit different. So we're supposed to figure out, so if you throw a ball from the ground on Mars, which has different gravity, and so if you have initial velocity, and as you throw it up, it's going to be slowing down as it goes up because of gravity. So the question is, how long is the ball going to be in the air, and then when's it going to be? What's the high point for that? So if we look at velocity, that's going to be, we have the initial velocity, but then we have this function, this part of the function here that's slowing it down, the acceleration. So negative 3.711 times time plus the initial speed there. So velocity times, or sorry, acceleration times time is velocity. And that's what we're getting for this first part, and then we have an initial velocity. So it's going to be thrown up and comes back down. And this would be considered time 0 here. Now, we want to figure out how long it's going to be in the air. There are probably some shortcuts we can, I know there are shortcuts we can do to find that. I'm not going to do the shortcuts because I want to teach the calculus side of this. What is different on this than what you might have seen in the book is that this starts at ground level and not at 2 meters or 1 meter or whatever. So just recall that our position, derivative of position function, is the velocity function. So our position is going to be the integral of negative 3.711 t plus 26 dt. And trust me, you need that second one to match up the answers. I was off a little bit, and I realized I didn't have the 2 1s. So that's going to be negative 3.711 t squared over 2 plus 26t. That's our position function as a function of t. And make sure that negative is clear there. Now we want to find out when that's going to be, plus c. Oh, someone's going to call me on, I bet someone already said that, plus c. The key to it though, since we were at the ground level to begin with, our initial value s of 0 is 0. So there's an initial value part of the problem. Now if we take that s of 0 equals negative 3.711 t squared over 2 plus, I should say 0 squared, shouldn't I? 0 squared plus 26 times 0 plus c, and you get 0. Well, you're getting 0 here, getting 0 here, so c must be 0. So we can throw that part away. Let's continue with this. We have then s of t is negative 3.711, I'm going to put the 2 here, times t squared plus 26t, then not equal 0. We're going to take that though. We want to know when the height is 0. When is the height down here at the ground? So if we take this, negative 3.711 over 2 t squared plus 26t, and set that equal to 0, we can factor out a t, so t times negative 3.711 over 2 times t plus 26 equals 0. You probably see where I'm going with this. We have t equals 0, and that makes sense. That's the initial time. That's when this starts. What's this other time? Well, that's when we take the negative 3.711 over 2 times t plus 26 equals 0. So negative 3.711 over 2t equals negative 26, or t equals negative 26 over negative 3.711 over 2. And for that, I got 14.012395558. There's a run out of space to write that. Okay, so up here I'm getting 14.012395558. I think they'll only wanted 4 decimal places, but The next part is how high will it go? Well, realizing that this is going to be a parabola, what comes up comes down. It's kind of cool that way. And here's 0, and then this is our 14.012395558. The midpoint is where you're going to have the peak. And this is an easy calculation because it's symmetric here. Well, I shouldn't say symmetric. It starts at 0 at 0, so I don't have to worry about another calculation. So we want to get that peak, so we're going to take that 14.01239558. And honestly, I think it's best if you don't retype it in the calculator because you can transpose numbers, and the number stored in my calculator is much more accurate than what I have displayed. It has more digits, but the display only goes so far. We divide that by 2 to get the time for the peak. And then we're going to take that number, and I'm going to put it in here, S of, I have that number, it's going to be 7.00619,779. Again, I would recommend getting that stored in the calculator, then you can have, well, I'm on the TI-84. When you're typing in the next set of calculations, you can have that full number that goes beyond what's displayed input. So S of 7.00619,779, and that's going to be, so this gives us our position or the height. In this case, I could have said H, but I just left it as S for position. So we're back to negative 3.711 divided by 2 times the 7.006. See, I already wrote something wrong. 619,779. We're going to square that amount, plus 26 times 7.006, 19779. So we take that amount and we get the height. And it took me a couple times because it kept having little errors in the calculator, my own errors. 91.08057127. And that's the height it reaches. So I come up here, 91.08057127. That's it. Okay, I hope that helps.